Okay, so there's quite a few hydrologic forecast tools that, or I would say products that the CNRC delivers, and I'm going to touch on a variety of them and just kind of break it down into categories. I'm going to talk about our deterministic or our single value forecast, which is a short range product going out 5 days. I'll talk about a short range ensemble forecast products, and finally get into some of the long range ensemble products that we offer on our webpage. So the deterministic or our single value graphical products, Dan was talking about our QPF and our freezing level forecast and our temperature forecast, which are single value forecasts. So what we do is we run hydrologic models. We have a snow model and soil moisture model. So these are continuous simulation models. There's a little background on the model. So they're constantly tracking the antecedent conditions of the watershed in terms of soil moisture and snowpack. And so these hydrologic models track the conditions of the watershed, and then we feed it both observed precipitation going back and temperature and freezing level going back 10 days. And then we also feed it forecast precipitation, temperature, and freezing level going out 5 days. So the end result is a single value hydrograph for all the locations that we provide Streamflow forecasts for. And these are just two examples. We have one for a river forecast point on the left, Yuba City, Feather River at Yuba City, and then one on the right, which is the New Lords Bar inflow forecast. So it's important to point out that we provide Streamflow forecasts at a lot of river locations, both downstream and upstream of reservoirs, but we also provide inflow forecasts to quite a few reservoirs throughout California and Nevada. So the previous slide showed just the graphical forecast products, which you can view. A lot of our partnering agencies like to ingest the actual time series into their decision support tools for reservoir routing and decision making. And we have a few different website links where you can go to actually download the CSV files. And what I have here is a screen capture. There's a website above the screen, above this image, and that's where you can get a CSV file for the various forecast groups. We kind of group a lot of our Streamflow forecast products into kind of regions. And so we have like a Klamath, North Coast, Russian Napa, Upper Sacramento, Feather Yuba, and so on. So you can go to this website, click on the link, the file name link, and download that CSV file. There's also another way to get, and so in that file, you'll basically get Streamflow forecasts for every location within that group. If you want to just get the tabular data for a particular location, you can get that from the graphical view that we were showing previously. There's a button above the graph, and I have it circled in red here, CSV, and you can just go grab the CSV just for that particular location. And if you notice on the right-hand side of the forecast group CSV download, there are little links to Adobe files. And what those are basically ID translation. All of our Streamflow forecast locations have a 5-character ID. Not very descriptive to most people. So if you go to that CSV download site and click on one of those forecast group Adobe Acrobat files, you'll get a description of what each one of those IDs in the CSV represents. So this is an example for the Feather Yuba. Now we'll talk a little bit about our short range ensemble forecasts. We provide ensemble Streamflow forecasts for hundreds of locations. And just a little background on that is the Streamflow, ensemble Streamflow forecast, basically it takes into account weather model, short range weather model uncertainty within the first couple of weeks. And beyond that, it's using climatological forcings that drive the hydro model response. And so when I say climatological forcings, it's basically historical temperature, precipitation, freezing level from historical years. Currently, the historical years are 1980 to 2020. But for the short range, the spread of the uncertainty in the stream flow is really driven by the uncertainty in the short range weather models. And primarily it's the GEFS, which you've heard reference to quite a few times through the earlier presentations. The first 3 days of the ensemble stream flow is driven by the uncertainty in the QPF coming out of the CNRFC, and then days 4 to 14 are the uncertainty in the GEFS. A new short range ensemble graphic that we developed this year. Again, Dan thanked Kyle Lerman. I'm going to thank him again. He helped develop this interactive product. You know, Dan had talked a lot about how, you know, static images, going from static images to more interactive displays, and in terms of looking at QPF and freezing up and all that stuff that he talked about. But we also are trying to do that with our Streamflow forecast products. So I'm going to click on this link here that I think will bring up an example. Okay, hopefully everyone can see this. This is an example. This is not real time. We don't have a flood threat situation going on here. This is a past event on the Walker River in 2017 during snowmelt season. And so what you see here are our deterministic forecast, which is in black. And then you have the spread of the ensembles summarized by probabilities through the color shading. And all that is kind of described in the legend over here. And up here to the right is sort of a summary, statistical summary of your viewing window. So right now we're looking at a viewing window of roughly 5 days. And so what it's telling us, based on the uncertainty in the stream flow, that there's an 85% chance of reaching flood stage within that 5-day window that we're looking at. And if we zoom in to a tighter window, I'm just going to zoom into this. Now it's basically saying that there's a 0% chance of reaching flood stage, but there's a 7% chance of reaching our monitor stage within this window that we're viewing. So these summary statistics on the fly update based on your viewing window. And you can go out to 10 days. This is the maximum length that we have for interactive product. Okay, I'm going to go back to the presentation. Everyone see that okay?
Yeah, looks good.
Okay, so now I'm going to go to another short range ensemble product, and this is more driven for the water management community. The previous product was more based on peaks. So if you're looking at river locations and want to know exceedances of certain flood stages, that's a valuable tool. This next product is looking at cumulative volume based on the ensembles. So this is an example for New Bullards Bar. What day is this? 2019, I guess, March. So what we have here is our deterministic forecast, again, shown in black. So that's kind of the cumulative volume, about roughly 30,000 acre feet coming into New Bullards Bar for this example, over a 5-day window. And then you can see the ensemble spread. Each one of these light red lines are ensemble trace. And the probabilities are then highlighted with the dots. Let's see. Go. Thought that link was live, but it doesn't look like it is. So I'll just go ahead and tell you. We also tabulated all these values for the different accumulation periods, 1 day, 2 day, 3 day, 4 day, for all the different probability levels. There's a tabular, there's a table below this graphic for all the different locations, so you can actually get values and not just try to read them off the graph. We do have some other short range Ensemble products, 10-day probabilities, that are available on our webpage. And before, we did have some short range plots called the 5-day peak and 10-day traces. So those that are familiar with our website have probably seen those before, and those are no longer there. And the short range Ensemble graphic that we talked about is now in its place. So now we have a single button short range peak, which corresponds to that interactive graphic we just went through. And that really provides all the information that was in those other two static images, plus a whole lot more. So it's a much more powerful tool. Just as with the deterministic forecast, we also provide CSV file downloads for all of our Ensemble Streamflow forecasts. So the look and feel is very similar to the deterministic, but if you wanted to download every member right now, like I said, there's 41 members now that we have. So if you wanted to download all the time series for particular locations and process them through your decision support tools, you can get them from the provided link above this image. And there's also the ID help documents as well for the short range ensembles. So my last thing I'd like to talk about is the long range products. So our Streamflow Ensemble forecasts, when we run them in the morning, they go out a full year. So it's starting with the initial conditions, the antecedent conditions at the time. It's being forced with different temperature and precipitation possibilities over the first couple of weeks that are driven by uncertainty in the short range weather models. And then beyond those first couple of weeks, we're feeding it, like I said before, with climatology. And so that gets us out to a full year. So you Streamflow time series, 41 different Streamflow time series for all of our forecast locations going out a full year. And so, those long range time series are good for summarizing some of the seasonal trends, especially the April, July runoff, water year runoff. And so we can go through an example there. So right now, this is the seasonal trend plot. So this is our April, July runoff forecast. So what we have here are our best, our 50% forecast is showing for Lake Oroville right here, showing a little over 1 million acre feet. And then you can see the spread, the 25 and 75 sort of in that light purple. And then we have the 1090 in light gray. And then over here this is our April, July runoff sort of window, which is defined by these vertical black lines, and just the average accumulation and the median accumulation over time. So, and above the graphic, you can get a summary of what the current forecast is. So our median forecast is showing about 92% of the historical median and 75% of the mean. And this is what the forecast, the April, July forecast runoff volume for today is. So if you want to see this for maybe a different year, one that's actually happen, you can go and look at some historical years. Right now, it looks like we have from 2011 all the way through 2022. You can look at how those forecasts tracked over time. And so obviously your spread is very wide out at the beginning of the water year, and it narrows as you get closer in time to the actual runoff, AJ runoff period, and gets extremely tight once you get within that period. It's good to point out that these ensemble forecasts really take into account meteorological uncertainty only. So they do not take into account hydrologic uncertainty. If they did, the spread would be a little bit broader, especially as you get into the time period where meteorological uncertainty becomes small, and really it's just hydrologic uncertainty left at that point. And I won't go into all the details, but there's also a build your own interface where you can query the time series and get certain products. For example, if you wanted to look at the total volume, this is again Lake Oroville summation over an entire period. And let's say we'll start today and we'll go through, let's just go through a full year. October 15th today, October 14th, 2022. And we'll look at some probabilities of what that total accumulation volume would look like from today going out a full year. You can get some static images based on that. So you can obviously download the time series and bring them into your own decision support tool, but you can also use this interactive tool if you want to query the time series themselves. There's also some historical flows and some verification and other things that I won't get into, but just want to bring some awareness to both short range and long range ensemble forecasting tools that we have for many locations throughout California, and quite a few within the Feather Yuba watershed. Let's see here. That does it for me. So that's the last slide I have in my presentation.